Hey all, welcome back to my channel Physics with Varnika. So in the last video we have learned about gradient, divergence and curl. Gradient is when a del operator operates on a scalar function. Divergence is when a del operator operates on a vector function via dot product. And curl is when a del operator operates on a vector function via cross product. So in this video, we will learn about two important properties with the combination of these three. So the first property is divergence of a curl of a vector is zero. Suppose let the vector A is axi cap, ayj cap, az k cap, and we know the value of del operator is I cap del by del x, j cap del by del y, k cap del by del z. So we have to find the divergence of curl of a vector is 0. We have to prove that the value of this is equal to 0. So first curl of a vector means we have to operate the del vector to the vector function via cross product, and divergence means we have to operate the del operator with a vector function via dot product. So we have to find out the value of this. Means we have to prove that the value of this is 0. So first of all, write down the value of del operator, which is I cap del by del x, j cap del by del y, plus k cap del by del z dot product. And to find the curl of A, we have to use the determinant method. I cap, j cap, k cap del by del x, del by del y, del by del z, and ax, ay, az. The value of del operator. So first of all, solve the value of determinant. I cap del by del y az minus del by del z ay minus j cap del by del x az minus del by del z ax plus k cap del by del k cap del by del x ay minus del by del y ax. So as we have to do the dot product here, so only the component of I will be as I dot I and j dot j and k dot k will be 1, and I dot j, j dot k and k dot I will be 0. So only the component of I with I will be multiply in the dot product. So we will get del by del x, del by del y, az minus del by del z, ay minus del by del y, del by del x, az minus del by del z, ax plus del by del z, del by del x, ay minus del by del y, ax. Now multiply, we get del square az del x del y minus del square ay del x del z minus del square az del y del x plus del square ax del y del z plus del square A y del z del x minus del square ax del z del y. So as we can see, del square ay del x del z, del square ay del z del x will cancel out as they are the same. Del square az del x del y del square az del x del y will also cancel out. And del square ax del y del z del square ax del z del y is same, so they will also cancel out. And we finally find 0. Hence, divergence of curl of a vector is 0. Now the next property is curl of gradient of a scalar is 0. So let we have a scalar, let scalar phi is x, y, z be a scalar function and the value of del is I cap del by del x, j cap del by del y, k cap del by del z. So the value of gradient of phi means del operate on a phi function will be I del by del x, del phi by del x, j del phi by del y, k del phi by del z. So what we have to find, the curl of gradient of a scalar is 0. We have to prove the value of this is 0. So when del operate on this function, this is gradient of a scalar. Curl operate means we have to cross product here. We have to operate the function via cross product. So by determinant method, we will find it del by del x, del by del y, del by del z. And here the component of phi function del phi by del x, del phi by del y, and del phi by del z. Solving it, we will get del y del phi by del z minus del by del z del phi by del y minus j cap del by del x del phi by del z minus del by del z del phi by del x plus k cap del by del x del phi by del y minus del by del y del phi by del x. Del square phi del y del z minus del square phi del z del y minus j cap del square phi del x del z minus del square phi del z del x plus k cap del square phi del x del y minus del square phi del y del x. So here as the values are same, so they will cancel out. And finally we get the answer is 0. So these two are the very important property with the combination of gradient, divergence and curl. The first is divergence of curl of a vector is 0 and curl of a gradient of a scalar is 0. So that's it for today. Thanks for watching.